Alright guys, welcome back, and now we're going to be looking at the last part of factorization, which is factorization by difference of two squares. And you find that these are very simple in comparison to factorizing quadratic expressions. In fact, these questions are two steps and normally worth 2 marks in the exam. So let's get straight into it. So we're going to be looking at the first two questions, very simple questions, and it says factorize completely 9x squared minus 4. Now remember we said that this is factorization by difference of two squares, and in mathematics difference means subtraction, and what we're going to essentially be doing is trying to get these as squares. So we're going to get straight into this now. So our first step is going to involve writing this as a square, and you'll find that 9x squared is the same thing as 3x all squared, because 3x all squared simply means 3x times 3x, which is 9x squared. Minus, and again, we're looking at the 4, and we're trying to write it as a number squared, and of course 2 all squared means 2 times 2, which is going to give us 4. So now you can clearly see what we mean by difference of two squares. Alright, the difference of two squares. So the trick is trying to write each of these as a number or a term squared, and of course a minus comes inside. Now if it's not subtraction here, then clearly it's not difference of two squares. It could be simple factorization or factorization of a quadratic expression, so you have to be careful. So it has to be a minus here, and of course the final step now is going to be, and this is where you have to look at it carefully now, it's going to be 3x minus 2 in one bracket, and in the other bracket 3x plus 2, and I'm going to explain this in a second. So if you remember, we said that factorization is the opposite of expansion, and in factorizing this by difference of two squares we get that. Now 3x times 3x is going to give us about 9x squared, and 3x times positive 2 is going to give us 6x. But if you look back at here now, minus 2 times 3x is going to give us 6x, and 6x minus 6x is 0, and then minus 2 times positive 2 is going to give us 4. So it's two different signs inside the bracket all the time when it's factorization by difference of two squares to get rid of the middle term. So we only have 9x squared and the 4 there. So just two steps. So the first step is writing the first term as a square and the second term as a square, and then in the bracket 3x comes here, the 2 comes here, in the other bracket as well, except that we have two different signs. So if you try to expand this back, you're going to see you're going to get about the exact same thing, because the middle piece is going to subtract itself. So let's take a look at this now. So again, 4x squared can be written as 2x all squared minus, and 100 is 10 all squared. So the final answer will be 2x minus 10 in one bracket and 2x plus 10. And again, the two signs must be different when it's factorization by difference of two squares, because it allows us to get rid of the middle piece and just end with the first and last piece. Alright, so again, you can expand this on a sheet of paper and you'll see for yourselves that it's going to get rid of the middle piece. 2x times 2x is 4x squared. 2x times 10 is 20x, but then it's going to go because it's going to be subtraction here. Minus 10 times 2x is minus 20x, so 20x minus 20x is 0. And then minus 10 times positive 10 is minus 100. So I'm going to slide this over here so you can see the consistency with the other two that we're working here. Very easy. Again, x squared is the same as x all squared minus, and 1 the same as 1 all squared, difference of 2 squared. So in one bracket, we're going to have x minus 1. And in the other bracket, x plus 1. Why? X times x is going to give us x squared. X times positive 1 is 1x. Minus 1 times x is minus 1x. So 1x minus 1x is 0. And then minus 1 times positive 1 is going to give us the minus 1. So for this one, again, 36p squared is the same as 6p all squared. Because 6p all squared means 6p times 6p, which is going to give us 36 p squared, and of course minus 1 all squared, the difference of two squares. So it's going to be 6p minus 1 in one bracket and 6p plus 1 in the other bracket. All right, so we're going to look at the last two now and show you that it is very, very simple. So this is the difference of two squares, and again the trick is you've learned simple factorization by grouping, factorization of quadratic expression, and now difference of two squares. You have to be able to tell the difference between all of them so you can know what to do, and that only comes with practice. So bear that in mind as well. So let's take a look at this one. So again, 121 is the same as 11 all squared minus x all squared. So in one bracket we have 11 minus x, and in the other bracket 11 plus x. Here, very simple, 81 is 9 all squared, and 49m squared is the same as 7m all squared, because 7m times 7m is 49m squared. And the final answer, in one bracket, 9 minus 7m, and in the other bracket, we're going to have 9 plus 7m. And again, you can always expand to test to see if you were to expand, you'll get back the original thing. And very, 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 very simple. All right, guys. So you're going to make a note of these, and then I'm going to give you a few questions to try. So it's extremely simple, extremely simple. And also, if you were to look back at this, the first question that we did, or any one of them for that matter, but let's take a look at the first one, 9x squared minus 4. Now, my question is this a quadratic expression? 9x squared minus 4, it is. So you could have also approached it using a factorization of a quadratic expression as well, because you have 9x squared, which is the ax squared part. You have 4 here, which is a c, and what would be missing is the bx. And in that particular case, the b would be 0. So you could still go the root of quadratic, because this is a quadratic, because you can clearly see that there is a square here, there's no index higher than the squared, and there's no negative index. So this also classifies as a quadratic expression. So perhaps I should give you a challenge to see who could actually factorize this using factorization of quadratic expression method. All right, but we'll tackle that at another time. So just try to identify and see, based on what you have here and here, if you could actually factorize by difference of two squares. All right, to be dynamic in your solution. All right, so I hope you guys found this video insightful. I'll see you guys on the next video.